Alright, today we're going to talk about mirrors. The first thing we're going to talk about is the law of reflection. This is going to be true for anything that we do with a mirror. This is really simple. I kind of already took notes on it. But for the law of reflection, the incident angle will always equal the reflected angle every single time. Okay. Now we have to remember that the angles are measured with respect to the normal. When we start bending mirror surfaces, that's going to change things a lot. But angles are measured with respect to the normal. And the law of reflection is always going to be true for any mirror. Always, always, always true. So, first one we're going to talk about is plane mirror, or flat mirror. This is the one that you look at yourself in the bathroom with. So, we have a flat mirror, and we're going to label the behind the mirror part and the in front of the mirror part. So, we'll draw our axis. We've got our object. And let's just draw a couple of rays to look at the law of reflection, see what happens. So we draw one, draw two. And looking at that, those rays are never going to cross. At least not in front of the mirror. It's just not going to happen. Now with both of those rays, they have the same angle in and out. They are never going to cross. And so, what we're going to do is trace them back. They look like they're coming from the same place. They look like they originate in the same spot. So we'll trace them back. And we see an image formed there. Now looking at that image, it's the same size as our object. That's great. But it's behind the lens. We had to trace it back. And it's upright. So it is virtual, upright, the same size as the object, and it's behind the mirror. This will always be true for all flat mirrors. The image formed by a flat mirror will always be virtual, upright, the same size, and it's going to be behind the mirror. Every single time. This is how plane mirrors work. Plane mirrors are easy. We're going to move on to diverging mirrors. Now, a diverging mirror is a convex mirror. So we're going to draw one of those real quick. So, all these mirrors are spherical. When we're talking about the convex or the concave mirror. C and F here. C is the center of curvature. It's also the dead center of this circle. And F is half of C. It's our focal point. Now our focal point, C and F here, are both negative because they're behind the mirror. No rays could ever cross there. The outside of the mirror is facing to the right. These guys are behind the mirror. And our relationship, as always, is that the center of curvature is twice the focal length. Now, your mirror is not just going to be a solid mirror sphere. We're just going to deal with part of it. So I'm going to erase the circle part. I just wanted you to see that it was a circle, and it's easier to draw that way. Now, we just have one little convex surface. So, let's put it in our object on the correct side of the mirror, and let's draw our first ray. So this is going to be just like what we did for lenses, except for we're doing mirror stuff. So this thing comes in parallel, and it's going to go out as if it came from the focal point. So we'll go ahead and draw that, and then erase the focal point part. So it's in parallel, out as if it came from the focal point. It's diverging away. The next one, We're going to go in as if we're heading towards the focal point. We're going to go in as if we're going to go through the focal point, and then we're going to go out parallel. So in as if we're going through the focal point and out parallel. Again, you can already see these guys aren't going to cross, but let's do the last one. This one is in through the center, and it's out at the same angle. Now this is going to be tougher to draw on your papers, because you have to use a protractor to get to the same angle thing. So really the first two are good enough. But it's in through the center, out through the same angle. I drew it rather quick. Now, as you can see, those three things never cross. These rays will never cross. So we must trace them back. Again, this tracing back is something that our eye naturally does. All three of those rays that are coming off of it look like they're coming from the same spot. We trace them back. We see that an image is forming. This image is virtual because we had to trace it back. It's upright. It's diminished. And it's behind the mirror. Now guess what? It doesn't matter where we move this thing. It's always going to be true for every diverging or convex mirror. Every single time. This will always be true for a diverging mirror. The image will be virtual, upright, diminished, and behind the mirror. That's what diverging mirrors do. The next one that we talk about is a convex, a converging mirror. This is a concave mirror. It's the other shape. Now, we're going to draw it real quick. So, we'll put C in and F in. We'll go back. That's our sphere, where C is the center of the circle. F is the focal point, halfway between the center of the circle and the mirror. So there's the same relationship as before. This time, we're going to look at things happening to the right of this mirror. So we'll draw our axis, and we'll draw our object. Now, in this case, C and F are both positive quantities, because they are in front of the lens. Now we have a behind, we have an in front. So, let's draw our object. Let's draw our first ray. That's in parallel out through the focal point. The next one is in through the focal point and out parallel. You can already see where that image is, but we'll do the center. In through the center, out at the same angle. They all three meet at that spot. So we'll write it down. In through the center, out at the same angle. All three meet at that spot. We can draw our image. And we see that when we place the object at C, the image is the exact same size as my object. Very similar to what happened to a lens. Now we're going to place our object at different places. I'm going to leave this sketch up and draw it in different colors. So the next one we're going to do, we're going to place our object outside of the center of curvature. It's going to be farther away. We'll draw the first ray, looks the same. We'll draw the second ray in through the focal point, out parallel, and we see that they meet right there. And when we draw our image, again, it's inverted. And again, well, not again, we see that it's diminished. So if we're behind that center of curvature, my image is going to be smaller. And it's diminished. We'll do our next one. It's a different color still, blue. We're going to go inside of the center of curvature, and again, this first ray looks exactly the same as the other ones. So we go in parallel, out through the focal point. Then we go in through the focal point, out parallel. And we see this time that our image is bigger than our object. So if my object is in front of the center of curvature, the image is magnified. It's bigger. Now for all three of these cases, all images are from objects that are behind the focal point or further from the mirror than the focal point are real and they're inverted. Every single time my image is farther from the focal point. Now, I'm getting ahead of myself here, sorry about that. Let's do one in front of the focal point and see what happens. I'm going to use a little darker color because it's getting a little crazy over there. So, we're now between the focal point and the mirror. Let's draw our first one and our second one. That was too fast. So here's our first one, in parallel, out through the focal point. Then we're going to go in as if we came from the focal point, so this one's a little different. And then we're going to go out parallel. And you can see that these two dark purple lines are never going to meet. So we have to trace them back. Trace one back, trace the other back. And we can see that they meet behind the mirror. So we'll draw in our image. Now this image is magnified and it's virtual. So any image from an object in front of the focal point will be virtual, upright, and magnified every single time. So that's all we've got for these mirrors. We will do a little more practice with them.